we are going to do some applications that would be something a little more similar to a test prep type question with some of these. We're going to work on the odds together, and then we're going to have you work on some of the evens because it'll give you something to kind of base your work off of. Biggest key here, since they do give us pictures on a lot of them, is going to be figuring out where a lot of the values are going to go. So, all right, numero uno. We've got a sketch showing Mr. Smith's lawn and sidewalk on the side of his house where he needs to do some repair work on a high window shutter. Because the spring thaw has left the lawn too soft to support his 10-meter ladder, he must keep it on the sidewalk. So I can't bring my ladder way out here. It's got to be in here at a little sharper of an angle. The greatest safe angle from the ladder is 75 degrees, and his sidewalk is 2 meters wide. Can Mr. Smith do the repair work now? Here's the thing that's a little tricky with this one. Because we're so used to using all of the information to do our problem, we'd want to stick a 2 here. But here's how my question works. Okay, here's my 10-meter ladder. Okay, here's the spot where we're trying to get to this shutter. We're trying to figure out if this is going to work. We're trying to figure out if this area right here is only 2 meters wide or if it's shorter than that and I'd have to get into the lawn. So I can't plug the 2 in somewhere right away. Is X no more than 2 meters? That's what I'm trying to find. So I'm going to find out what this value is with my given degree and my given hypotenuse, the ladder, to figure out if this is going to work. So with this information, okay, I know my angle. I just said over and over, this is the hypotenuse. What side is X in relation to my 75 degrees? Adjacent. So which of my basic trig functions, sine, cosine, or tangent, use adjacent and hypotenuse? Cosine. So I'm going to have the cosine of 75 degrees equals my adjacent side, x, over my hypotenuse. And like we've done on a lot of these, now I need to figure out what x is going to be. So since I'm dividing it by 10 now, I have to do an opposite. So I'm going to go ahead, I'm going to multiply both sides by 10, and that would give me what my x value is going to be. And right, when I go to punch it in my calculator, just a reminder again, because I found out yesterday later in the day, I got some shady characters who are thinking it's funny to put things back into radian. Oh, even mine is. Make sure you're in degree when you're doing this, because if you're not, you're going to get some funky answers, but you're going to find that out quickly here. Otherwise, I can just type that in my calculator and get out the value. So here's my problem. Well, actually, it's Mr. Smith's problem. It's not mine. Since the sidewalk, okay, is this going to work out for me or isn't it? The greatest safe angle is 2 meters wide. Well, if it has to be 2.6 to get here, yeah, that's a little bit of a problem. Mr. Smith's going to have to find another option here, because his ladder is going to end up in the lawn, because this spot would come out to here because it's 2.6. It would be in his lawn. That's where I can actually put some application to use on these. But my bigger thing is, can you do this calculating at the start? And then we can figure out that type of question later. So let's see. We'll stay on our odds track here. All right. I can decipher this. We keep flipping along here with you. So number 3, in gathering information for the early morning weather report, an observer on the night shift at the U.S. Weather Bureau station turned on a powerful searchlight 1,000 meters from the control room. Okay, so let's see. 1,000 meters from the control room. So there's my 1,000, my distance between those two places. And measured the angle of elevation, looking up, from the searchlight to the spot it made on the clouds above to be 62 degrees. Okay. So my angle is 62 degrees. How high did she report the clouds were? In other words, from the control room to the cloud, how high was it? And for a lot of you, that's the biggest challenge you're going to face. Where do I put the numbers and where's what I'm looking for? So sometimes it may take thinking about it and looking at it for a minute. Okay, and I'm already being told tangent because we've got opposite, and with the 1,000 we have adjacent. So I would agree, opposite and adjacent is going to be tangent. So the tangent of 62 degrees would equal opposite over adjacent. And similar to what we had happen back in the last one, 1,000. And we just do our opposites and kind of run with this. So we'll get this guy plugged in. And if we go to the nearest meter, looks like those clouds were about 1,881 meters up in the air. Quite a little distance. Because again, most of us can't just walk up or fly up to something that's almost a mile high and figure it out. So we use math with things that we can figure out to figure out things like that. How low are the clouds lying? Stuff like those. So, all right, next one. Oops, wrong way. I stapled these kind of funny. All right. So now we got a cruise ship. All right. The SS Princess. A cruise ship heads out to sea from Port City, here, in a direction that makes a 47-degree angle with the coast. Okay. So here's the coast. Here's where I'm sailing. So I got this 47-degree angle. After sailing along for 82 miles, all right, so since I'm going this way, that's my 82 miles, the ship has passed the captain's hometown, Leesville, located has it passed the captain's hometown, Leesville, located 59 miles down the coast. So once I get to here, the question is, how far down the coast have I been? Now some of you are like, why don't I just put 59 there? Because that's what we're trying to figure out. Am I 59 miles down the coast? Okay. Has it passed it? So I guess I should say, am I more than 59 miles down the coast? Thank you. So, I'm not going to use the 59 when I'm initially doing this. My right angle would be with the coast, in case you're wondering where that might be. So I got to figure out again what sides I've got. I got the hypotenuse, I got the long side here. I don't have the opposite side, so this would be my adjacent. So we're going to be using cosine, right? So the cosine of 47 equals my adjacent over my hypotenuse. So let's see here. We're going to multiply both sides by 82. We know that to get x alone. So let's see if we've passed the old captain's hometown here or not. Looks like we're about Nope, definitely have not yet. Soon, but not yet. Because we definitely are not 59 miles down the coast yet. So the trig allows me to figure out information like that and see how far along I am. Again, this is how airports even figure out, you know, are you on time? Are you going to be arrival? I mean, you don't know when those people are way up in the air, but they can look at where they're at in comparison to where they need to get to and can figure something like that out. All right, 7. Falls City has recently increased property taxes in the valley so much that the Mountain Electric Company can no longer make a profit on the electricity it produces at its generating plant there. Things happen like that locally too. The company owns land outside the city, 989 yards up, okay, it's already marked for me, on the mountain on the same stream it now uses. But the equipment it has will not work at an elevation greater than 300 yards. Okay, we'll keep that in mind. Can the company use that equipment on its land up the mountain if the stream makes a 17-degree angle with the valley at its present point? Okay, notice I haven't put the 300 anywhere yet, because again, that's my question. Is the elevation greater than 300 yards? That's what I'm trying to figure out. So, if this is where it is now, and here's where it's going to be, and I'm trying to figure out elevation, that's what I need to figure out. And again, as long as I have one value and an angle, I can use my trig functions to figure this out. So which sides do I have this time? Opposite and hypotenuse, which would be sine. Opposite over.
So if it's under 300, it's okay? Or does it have to be right now?
No, anything below would be okay too. So I go ahead, I multiply by my 989 to both sides. And let's see if we're going to make this move or if we're going bankrupt. Oh, we squeeze in. So since we're under the 300, we're okay. Our equipment will still work. And again, this is why the guys or gals that can figure this out make so much. Because that'd be a lot of money if you had to buy all this new equipment. But if you can find out you can't, you can just move. Hey, that's even better. All right. We're getting there. Retrospect, I probably could have given you guys more of these and not had to do quite so many, but that's okay. All right. Ooh, no picture. All right, here we go. Mr. Fly is a flying instructor, who will take customers up in his small plane for lessons any day the clouds are more than 1,125 meters high. Today, at the moment, a weather balloon disappeared into the clouds directly over the airport Mr. Fly uses. Another observer, 579 meters away, saw the balloon at an angle of 62.5 degrees. Will Angel and Billy be able to take a flying lesson with Mr. Fly today? Okay. So let's check this out again. So we have an observer that's 579 meters away. Here is our observer. Saw this balloon floating around at an angle of elevation of 62.5 degrees. Like, where's the 1125? Oh, yeah. That's what I'm trying to figure out. Is the balloon less than 1,125 meters high. If it's less, they get to go up flying. If it's not, well, they're going to have to pick a different day. So I'm like, okay, what sides do I have to use with my angle measure? Opposite and adjacent, which means working with tangent. And again, since my x is in the numerator, I can just multiply both sides by 579. All right, let's see if we're going flying today. Everybody keeps getting good news on this, so we should give everybody good news all the time. And we're still giving out good news. Okay. There will be flying today. The balloon is not up over 1,125 meters, so we're all right. Wait a minute. Yes, because I can still see the cloud. For a minute, I thought I was answering a no with a yes, but no, that one would be okay. All right. Last one, and I'm going to make note of something for you on this one. Number 11 and number 12 go together with the exact same angles. So let me make a note of this. Okay. This 13-degree angle that we are going to use in number 11 will be the same 13-degree angle you're going to use in 12 because they're not going to mention it. So you'll see in a minute where that angle's at, and that should help you to be able to finish that one. So, all right, let's see what we got here. Mr. Tinker found the insides of an old grandfather clock with a pendulum that swings through a 13-degree angle from the vertical to its highest point. In other words, right there. And when they say the vertical to its highest point, it just means we start, here's my vertical line, my straight up and down, and when it gets to its highest point, it's been 13 degrees in this direction. The pendulum is 85 centimeters long. Okay, they already did that for us. He wants to hang it between two sections of shelves in his den. How much space for the pendulum swing must he allow on each side of the clock? Well, they're even nice and tell us where x goes. Now, here's where I've got to be a little bit cautious. I go, okay, got an angle. Here's the side I'm looking for. Here's my pendulum. Okay, what sides were we working with? Opposite and hypotenuse, which is sine. So opposite over hypotenuse. So I look at this, okay, I multiply both sides by 85. And if we were trying to do this on our own, there'd be one more thing we're going to have to take into consideration here. And if we round to the nearest, we'd say 19. Okay. Again, that's on each side of the clock. So if you were trying to figure this out yourself with shelving, okay, I mean, it would be 38 centimeters total. I know they only asked for one, but I always like to put in little thoughts on when you're thinking about these, because you don't say, oh, I need 19 centimeters. Somebody might say, oh, it's total of 19. I can do this. So that's what you're going to use, though, when you do get to number 12. That angle at the top is still going to be that same 13 degrees. And then it's going to make you think a little bit. It's not exactly the same in that if I start reading on 12, it says, years after buying the grandfather clock, Mr. Tinker and his wife sold their home and moved to an apartment so small they needed to sell most of their furniture, including the clock. The antique dealer who bought the clock paid top dollar for a clock if at its highest point the pendulum was at least 3 centimeters higher than when it was hanging straight down. So in other words, when it's hanging down here, I need to see how much higher is it when it gets to here versus when it's down at the bottom. So I will give you one hint. We remember before, and I'll even make mention of this, it told us in problem 11 it's 85 centimeters when it's vertical. But here's what you now are going to be trying to think. Once you figure this out, given the information that you have, because now again I'm not looking for this, I'm looking at this, you're going to have to take whatever value you get and subtract it from the 85. That's going to tell you how far it is here. So once you find this out, subtract it from the 85 and find out if it's that 3 centimeter difference or not. I'll give you that much. So there's a slight tweak in how it's going to set up versus 11, but once you get that x value, then you're going to need to find out, just subtract that. I'm already talking too much. So your job is to knock out the evens in here, and then tomorrow we will get into law of sines and law of cosines and get back into some regular stuff and away from some of the story problems for a bit.